work a problem on normal distribution. So, this problem states the average SAT score is 1028 with the standard deviation 92. Question number 1, what is the 90th percentile SAT score? And number 2 is a random sample of 100 SAT scores are selected from the population. What is the probability that the sample mean exceeds 1050? Okay. So, of course, we'll assume a normal distribution. Assume the SAT scores are normally distributed. The relative frequency of probability is highest, and that is mu equal to 1028, and standard deviation is 92. They want us to find out the 90th percentile. 90th percentile score means 90% of the scores are below that particular score. That is the 90% of the scores are below the 98th percentile. Now we know the left half of a bell-shaped distribution is 50%. We always start from the left, 50% here. 90% is greater than 50%, so not only 50% of the left half and a little bit more will get us the 90th percentile. So we draw a vertical line somewhere over here to make the bell-shaped curve, such that the area on the left of this particular vertical line, this area is 0.9, this area. And we want to find out this particular score such that 90% of the scores are below it. So X is the 90th percentile score. 90th percentile score. And 90% of the area under the normal curve is below X. Okay. So we will use TI-83 calculator, and we will press the second button, then the verse button. Second button is in the top left of the calculator, TI-83 or 84. Verse is in the third row, and then we will select number 3, which is in norm. This function is used when we know the area to the left of an unknown x, such as in this case, the area is 0.9. So the first argument of the first term we have to type in the calculator is area below the unknown x is 0.9, to the left of the unknown x. Mean is the mean of this distribution, which is 1028, and sigma is 92. Then we go on paste and hit enter twice. This will give you the 90th percentile score. So let me try that with my calculator. Here is my calculator, so I put it on. Okay, then I press the second key on the top left. Then the verse key is in the third row, like I was saying. And then I will select number 3, which is in norm. My area to the left of the unknown x is 0.9. So the first line I type 0.9. The mean is 1028. In the second line I type sigma, the standard deviation is 92. Okay. And then I go down on PEST. Like I mentioned, on PEST you have to hit enter twice. And this particular score is 1145.9. So 1145.9, which you can of course round to 1146. So that is your answer for part 1. The unknown score below which 90% of the scores fall is 1146. Okay, if you have any question, drop me a comment. I'll get back to you as soon as possible. Okay, so next we are going to do part 2. There's a little bit of difference here in part 2. What we are doing in part 2 is we are selecting a simple random sample of 100 SAT scores, and we are going to deal with the sampling distribution of the sample means. So part 2 is sampling distribution. Sampling distribution of x bar or sample means. So we have x bar, okay, and our sample size n is 100. Now from central limit theorem, let me first draw the area, draw the normal distribution, bell-shaped curve. Okay, the center where the peak is the highest by central limit theorem, this is called mu x bar, okay, because we have x bar on the horizontal axis, sample means, and our sample size is 100. So from central limit theorem, if you have watched my previous live session, from central limit theorem, mu x bar is equal to mu of the population or mean of the population, which is 1028. However, the standard deviation of the sampling distribution, sometimes called the standard error of the mean, is sigma divided by square root of n. So in our case, sigma is 92 divided by square root of 100, or 92 divided by 10 divided by 10. So sigma x bar is 92 divided by 10 is 9.2. This is important. So the mean of the sampling distribution is equal to mean of the population. The standard deviation of the sampling distribution is 1/10 of the population, because the standard deviation of the population is divided by square root of the sample size. Sample size in our case is 100. Now we have to answer the question, what is the probability that the sample mean exceeds 1050? Now the center is 1028, mean of the population. Again, we notice that the sample mean is 1050, which exceeds 1028, the center. So 1050 will be maybe somewhere over here, 1050, and we want to find the probability that the sample mean exceeds 1050. That means if we draw a vertical line at 1050 to meet the bell-shaped curve, we are interested in the area to the right of 1050. Okay, so probability of x bar to exceed 1050 is the area under the normal curve or sampling distribution curve to the right of 1050. Okay, so we will use second button again in TI 8384. Verse is in the third row. However, this time we will use number 2, which is normal CDF Okay, the first star line says lower. Lower means where do we start our calculation from? Is 1050. Now upper is where the curve ends, curve ends. As you know, the standard normal curve or normal curve, bell-shaped curve exceeds to infinity. A very large number on the right side to remember. And that in the calculator is indicated by, first we type 1, okay, then the comma buttons, second and comma button. Second button on the top left, and then the comma button. You ask where is the comma button? It's on top of the 7 button. It's on top of the 7 button. So second button and comma. Why do we do all this? Because we want to get a E, which stands for exponent. And then we type 99 after that. That means this is a very large number on the right, which is 1 followed by 99 zeros. E stands for exponent, or 10 to the power of 99 in this case, 1 followed by 99 zeros. That's my upper. My mean is same as before, and that is equal to 1028. And my sigma, remember this sigma is 9.2 because it's the standard deviation of the sampling distribution, which is population standard deviation divided by square root of the sample size, is 9.2. Then you go to paste, enter and enter. So let's do the calculation. Here is my calculator. Okay, I put it on. Then second button, burst button. Now I'm going to use number 2. My lower is not minus 1 E99. That means a very large or very high negative number on the left. We are starting our calculator. So change the lower to 1050 because that's where we are starting our calculation from. My upper is 1. Then second button and comma button gives you the E exponent 99. This line basically tells the calculator that the upper boundary is 1 followed by 99 zeros, or a very large number. My mean is 1028, and my standard deviation is not 92, it is 9.2. Okay, because it's the standard deviation of the sampling distribution. Then I go on paste. Like I said before, on paste you have to hit enter twice. Enter and enter. And the answer is 0.0083. That's your answer for part 2. Again, to summarize what we did for part 2 is we are going to calculate the area to the right of 1050, which is one value of the sample means on the horizontal axis, which is sample mean. We want the area to the right of it, so we draw a vertical line to meet the sampling distribution. This curve, by the way, is the sampling distribution of x bar. And we start our calculation from 1028, and upper boundary is a very large number on the right, which is 1E99. My mean is 1028, same as the population mean, but my standard deviation is only 1/10 of the population standard deviation, is 9.2. So the probability comes out at 0.0083. What does it mean? It means there is a 0.83% chance that the sample mean of a sample of size 100 will exceed 1050. Or in other words, very small chance that the sample mean of a sample of size 100 will exceed 1050. Okay, so I'm going to stop here today. If you have any question, do not hesitate to write me a comment. I will get back to each and individual comment. If you like this video, please give me a thumbs up. I really appreciate that. And please subscribe to my channel by hitting the red subscribe button, and please do not forget to click on the bell button because that will notify you every time I upload a new video. Okay, And again, if you like this video, share with your friends. Thanks for watching. Take care. Have a nice day. I'll see you next time.